Hello, my name is Wei. Today I will introduce one audio effect I created by Max. Here we are. We could see the Max here, and we listen the original audio file first.
The mind is time, the mind is space. A horn rush, a bass flush for minds to taste.
Now is the effect I designed.
The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space. A horn rush, a bass flush for minds to taste. The mind is time, the mind is space.
Here we are. This module A is a filter delay. The module B is a filter. Then module C is a wave shaper. And the routing is audio signal from the module A going to the module B, then module C, and back to the main output, L and R. I use a send and receive object routing without any patching code, which enable the signal routing freedom by Max. I send I and R to module A, receive I and R, then send the signal from the output of the module A by using send and receive to the module B and module C. Then finally the signal from the output of the module C by send LA and send RA to the receive LA and receive RA to complete the signal routing. This is B-patcher, makes the design much easier. Now I'm introducing the module A and its design principle. In presentation mode, we could see clearly that there are 4 default setups for this filter delay: winter, autumn, spring, and summer. Then I set up different frequency and modulation value to make it more perfect. This is the dry-wet ratio setup. There is a feedback left channel and feedback right channel. Now we're going to the patching mode. The delay, I use the tap in and tap out to set up the delay. I set up the left channel tap in is 2500 and tap out is 250. The right channel is 5500 separately. Add an initial multiplier and controlled by a dial for each channel. The range is from 0 to 1. Then use another dial to control both of them to realize the wet and dry ratio control. And the range setup is from 0 to 1. Then is a feedback to create more than one feedback sound. The routine is the signal going to the input of the tap in and out of the tap in going to the tap out input, and out of the tap out going to the initial multiplier input, then output to the tap in input again to produce a feedback effect. And I set up two dials named FBL and FBR to control them separately and set up the dial value is 0 to 1 for each. Then I wanted the delay more obviously, so I use a resin object. Here we are. This is a resonant bandpass filter to be controlled separately by gain input, center frequency control, and the Q control. And I set up the input frequency control by the number box. Finally is the default setting. You could see I set up different default settings as I mentioned before by using the send and receive message control. I use the send and receive message object. It enables the message transfer without any patch calls. I name it winter, autumn, summer, spring. You could see I send the message to the max. I told it I will send the signal ST 0.2, SO 0.4, SF 100, SE 200. Then using the receive message to receive the different message separately. You could see. And then to control the different target separately. Here, SF to control the frequency. SE is control the modulation value. And ST and SO, I control the feedback left channel and the right channel separately. Then we go into the module B. Open it, the presentation mode. This is a frequency range, the lowest and highest. Then is a different note value control, half note, quarter note, eighth note, and 16th note. This is a background picture control. This is a frequency range control. This is some default setting, low pass, high pass, band pass, and notch. We go into the patching mode. Firstly, I use the SVF and selector object to create a low-pass filter routine. The cut-off frequency and resonance were controlled by two different dials. This is a cut-off frequency control. This is a resonance control. This dial controls both in the same time. And I set up the frequency control range is from the 40 to 16,000, and to set up this dial to 0 to 1. Then I created a sawtooth wave to modulate them by using the phasor. Then I use a snapshot to convert a signal value into a float message. When a bang is received or according to a specified interval, then connect the scale. Enable the signal be sent and controlled separately. You could see the input low is -1, the input high is 1, output low is 50, and output high is 16,000. Then I use a number to control the low and high frequency output range. Low frequency output range I set up from the 50 to 5,000, and high output is 6,000 to 16,000. Then I connect phasor to cause object to use the sine wave instead of the saw wave to control. Then use the different message setting to control the different tempo. For example, half note, quarter, eighth note, and 16th note. Finally, I use the U menu to display text as a menu. Locket, low pass, high pass, band pass, and notch. Because the range will be from 0 to 3, so I used an 8 object to make the range from 1 to 4 to enable them work well with the selector object. By the way, I set up the picture background. Here we are. Control for each module. When you click this button and click anywhere of the picture, it will be interesting. Now we're going to the module C. Open it. Here is a presentation mode, and you could see the different cut value setting: 200, 400, 600, 800, and 1000. Then could adjust the resonance value and the picture background control. This is a wave shaper. We're going to the patching mode. The main thing of this effect design is the multi-slider. Here we are. Set the number is 256 and the range from -1 to 1. Then use a buffer. Because the buffer accepted the milliseconds, so need use a snap tones object to convert time from sample to milliseconds. And the result is 5.805. And double click the buffer. You will see the result. Then use the peak object to connect between the wave shape and the buffer. Use the list funnel object to enable each sample from the multi-slider will be 1, 2, 3, and so on. Then use the lookup object, which is transferring function lookup table. Then use the high-pass filter to filter unuseful frequency by SVF. Here we are. Cut off frequency set the 40 and connect from the high-pass output to another SVF object. Then use the two dial control the frequency and the resonance range like I did before. Cut off frequency controlled and resonance controlled. Then set up different default cut frequency. For example, 200, 400, 600, 800, and 1000.
time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space.
Thanks for listening.
A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space. A whole rush, a base rush, the mind to taste. The mind is time, the mind is space.